Hey guys, I thought I'd do a walkthrough to show you where the product rule comes from. So I believe we started with f of x equals, big F of x I should say, equals little f of x g of x. And the idea here is let's find the derivative. And unfortunately, since I'm trying to show you the rule, I can't actually use the rule. So I'm going to go old school on this guy. And I'm going to take the limit as h goes to 0. So if I do that, I'm going to do f of a plus h, g of a plus h, minus f of a, g of a, all over h. So that's old school. Just literally replace x with a plus h for the first part, and then replace x with a for the second part, all over h as h goes to 0. So the problem with this is there's nothing I can really do to simplify, so I have to do a little bit of shenanigans. And yes, that's the technical term. So here we go. I'm going to leave a little space here because I want to draw attention to what I'm going to add in. All over h, so I didn't change anything, all I did was separate. So I need to add something and subtract something. Actually, I'm going to subtract and then add, but I have to do the same thing so that they cancel out, so I'm not actually changing the problem. Since I know where this has to go, I know exactly what to add and subtract, you guys would never know. So that's why this is just sort of a walkthrough. This is not something you'd have to do, but this is what you actually would need to do to prove it. So I'm going to subtract f of a plus h, g of a. But obviously, if I subtract it, I have to add it back in. Otherwise, I'm changing the problem. So I'm literally just subtracting this product and then adding the same product back in. Why, do you ask? Oh, good question. Well, the reason is because now I've sort of forced these common factors. Notice in the first part I have f of a plus h, and in the second part I have g of a. So let's take out those common factors and see what's left over. Let's see, that's going to leave me with g of a plus h minus just g of a. Then I'm going to take out a g of a, so plus g of a, and that leaves me with f of a plus h minus f of a, all over the same h. And you're like, ah, geez, why are you doing that? Well, look closely at the g of a plus h minus g of a. Try to just picture in your mind the g of a plus h minus g of a over h as h goes to 0. Isn't that our definition of derivative? Look over here. You have f of a plus h minus f of a over h as h goes to 0. That might even be more obvious as the definition of derivative because we actually used f. Here, let me separate them and you'll see what I'm talking about. So the limit as h goes to 0, check this out, g of a plus h minus g of a all over h times f of a plus h plus f of a plus h minus f of a all over h times g of a. So all I did was split it up, and so you can see each part by itself. So g of a plus h minus g of a over h as h goes to 0, h goes to 0, h goes to 0 for this, and there's no h over here, so it doesn't really matter. But this part right here, if you just look at this part, that's our definition of derivative for g. That's g prime of a. What does this become? Well, as h goes to 0, that's just f of a. Plus, if I apply the limit over here, I get the derivative of f at a times the g of a has no h in it, so it doesn't really make a difference. And there's your g of a. So f prime of x, if I just change these to x's, is g prime of x, f of x, plus f prime of x, g of x. So it might be backwards from what I did in class. It doesn't really matter because you're just adding anyway. So you have derivative of one, leave the other alone, plus the derivative of the first one, leave the other one alone, whichever one you didn't do. And there's your product rule. Okay? If you have any questions, let me know. I'm going to work on the quotient rule one soon, so be on the lookout for that. And I will talk to you later. Okay, thanks. Bye. Why do I feel like I just left like a phone message? Whatever, don't call.